Hey, welcome to the beginning of this series where we'll learn Python completely from scratch. Eventually, we'll also get into machine learning and data science. Python is one of the most popular programming languages today. It's easy to learn, powerful, and used just about everywhere, from building websites to powering artificial intelligence. But before we even write a single line of code, here's an idea I want you to think about. Programming is really about modeling the real world. That means taking complex, messy reality and turning it into something a computer can understand and work with. Why is that important? Think about gene sequencing. Scientists use code to analyze huge amounts of data and find patterns that can help predict diseases. Or think about that blurry photo of a black hole you may have seen. That image was created using about 5 petabytes of data. To give you a sense of scale, that's like stacking 50,000 copies of the movie Interstellar. To process that much data, you need code, smart, efficient code. And that's exactly why learning Python is so powerful. It gives you the tools to explore data, understand it, and build amazing things with it. Along this series, we'll use Google Colab to write our Python programs. Colab is a free browser-based Python notebook. To use it, all you need is a Google account. Just visit the website at colab.research.google.com. The link is also available in the video description for your convenience. Now let's create our first notebook and start writing some code. We'll name this notebook basic-data-types. Here are the key parts of the Colab interface that you should know. First, text cells. Use these to write notes, explanations, or even formatted math using Markdown. They're great for documenting your work. Second, code cells. This is where you write and run Python code. Just click inside, type your code, and press Shift and Enter to run it. Think of each cell like a mini program you can test instantly. Third, the Run button. You'll find it next to each cell. Click it to run the cell. Shortcut, pressing Shift and Enter also runs the selected cell and jumps to the next one. And finally, the sidebar tabs. These include files, variables, and settings. We'll explore these in more detail later in the series. Today, our goal is to cover basic data types and the operations we can perform with them. We'll focus on 3 main types: numbers, strings, logical values, also called booleans. As we mentioned earlier, programming is about modeling the real world. These basic data types are like Lego bricks, simple but powerful building blocks. Let's use a car as an example. A string can describe the car's color. For example, red. A boolean can tell us whether it's self-driving. That would be either true or false. An integer can define how many seats it has. For instance, 5 different cars will have different combinations of these features. This is how we begin to represent real-world objects using Python. Let's begin with numbers. In Python, working with numbers is very straightforward. To show the results, we'll use the print function. This displays the output on the screen. Here's a simple example. Print open parentheses 42 close parentheses. This prints the number 42. It's an integer, and in Python, its type is spelled int, short for int. If we use a number with a decimal point, like 42.3 or 1.0, the type becomes a float, which stands for a floating point number. Before we go further, here's a quick note. In Python, you can add comments to your code using the hash symbol, that's the pound sign. Anything after the hash on that line is ignored by Python. It's just there to help you or others understand the code. Now let's go through the basic operations you can perform with numbers. Print 3 plus 2, that gives 5. Print 5 minus 1, that gives 4. Print 4 times 2, that gives 8. Print 10 divided by 2, that gives 5.0. Note that division always returns a float. Print 7 /2, that gives 3. This is integer division, which drops the decimal. Print 7% 2, that gives 1. This is called the modulo operator, and it returns the remainder of 7 divided by 2. Print 2 ** 3, that gives 8. This is exponentiation, or 2 raised to the power of 3. Finally, print open parentheses 2 plus 3 close parentheses times 4, that gives 20. The parentheses are used to control the order of operations. These are the core math operations in Python. You can now try them out and experiment with your own examples. Strings are used in Python to represent and work with text. There are a few different ways to define a string. Use single quotes, use double quotes, or use triple quotes, either 3 single quotes or 3 double quotes for multi-line strings. Here are some examples. Print in double quotes the word line. Print in single quotes the phrase also a line. Print 3 double quotes, then first line, second line, third line. Then close with 3 double quotes. This creates a multi-line string. Now, if your string contains quotation marks, here's how to handle that. Print using double quotes. I'm a human. This works because the apostrophe is inside double quotes. Print using single quotes. I \apostrophe_m a human. The backslash escapes the single quote. Print using single quotes. I am a human. The double quotes are fine inside single quotes. Print using double quotes. I am a \double quote human \double quote. This escapes the double quotes. These techniques help you include quotes and special characters in your text. Concatenation means joining strings together. In Python, you can do this using the plus sign or simply by placing strings right next to each other. For example, print hello plus world. This gives hello world. Print hello followed immediately by world. This also gives hello world. Python automatically merges adjacent string literals. To repeat a string multiple times, use the asterisk operator. For example, print you talking to me times 3. And it will repeat that phrase 3 times in a row. These are some basic string operations. Later in the course, we'll explore more advanced features like string formatting, indexing, and built-in methods. Stay tuned. In programming, we often need to make binary decisions, things that are either yes or no, on or off, true or false. Whenever I think about this, I'm reminded of that moment in The Matrix when Neo has to choose between the red pill and the blue pill. The logical data type is like a digital version of that choice. In Python, this type is called Bool, short for boolean. It has only 2 possible values, true and false. These 2 values let us represent simple logic in our programs. For example, print true, print false. These are the basic building blocks of decision-making in Python. Python includes 3 basic logical operators. First, and, both conditions must be true. Second, or, at least one condition must be true. Third, not, this reverses the truth value. Let's go through some examples. These logical values and operators are essential for writing conditions, filtering data, and making decisions in your code. You can get a Boolean value, either true or false, by comparing values in Python. Here are the most common comparison operators. Double equals means equal, exclamation mark equals means not equal, greater than or equal to, and less than or equal to. Let's go through some examples. Print 1 equals 0, the result is false. Print 1 not equals 0, the result is true. Print 1 greater than 0, the result is true. Print 1 less than or equal to 0, the result is false, masnare. You can also compare strings. Print hello equals hello, the result is true. Print alpha less than or equal to beta, the result is true. That's because Python compares strings alphabetically. These comparison operators are essential. They let your programs make decisions. While this is simple with numbers, in real-world applications like genomics, comparisons can involve more complex objects. For example, when comparing genes, you might count the number of nucleotides in each gene, compare expression levels, which are mapped to numeric values, or rank genes based on experimental results. If direct comparison isn't possible, try converting your data into numbers or other comparable formats. That way, you can still use these operators in a meaningful way. That's it for today. Thanks for watching. Don't forget to subscribe and hit the bell icon so you won't miss the next lesson. And if you'd like to support the channel, there's a Buy Me a Coffee link in the description. Totally optional, but always appreciated.